channel and back to the tutorial for deep learning. Today we are going to discuss a new thing called that is R2U-Net, one of the very familiar deep learning model. The upcoming session will definitely go through the technically how it works. Today this session we are going to see what is R2U-Net and why we need and what are the applications and how it will help to achieve the image segmentation, especially medical oriented applications. So before that, you have to know what exactly R2U-Net. And before that, you all of you know about U-Net because R2U-Net is one of the familiar model, and even though so many advantages there, and it follows the basic concept of U-Net because U-Net generally consists of encoder, decoder, and followed by script condition also. So here we can now here R2U-Net is one of the well-known architecture, familiar architecture, always designed for the high accurate image segmentation, particularly useful for medical imaging. Moreover, it is the extended version of U-Net where indicating the recurrent and residual learning mechanisms here. So and also the main target of R2U-Net is it always helps to combines or integrates the recurrent residual convolutional neural network concept, which consists of residual connections as well as the recurrent convolutional layers. These always helpful to improve the future representations here. And generally the R2U-Net structure consists of two things. One is called residual connections, another called the recurrent convolutional layers here. First of all, residual connections, these are the connections from the ResNet where helpful to resolve the vanishing gradient problem because here it allows the network to learn and identify the mappings more quickly and easily, and also helpful to improve the training of deeper networks here. And moreover, RCL is these also apply the same convolution operation multiple times, and also these also helpful for the network and allow the network to capture the contextual dependencies in spatial features also, and also helpful to improve the ability to extract complex patterns from input images. And some of the key architectural components like it generally consists of encoder, decoder, and recurrent residual convolution blocks and residual learning here. These everything later go for internally with mathematical functions, how it support like that. And why this R2U-Net is familiar and important because it always combining the two process, that is recurrent processing and residual connections. These always help to effectively capture both local details and global context also. And also it follows the standard U-Net when you go for complex segmented task here. And more, it follows the structure of encoder decoder with skip connections were helpful to preserve the spatial details. And then these facilitates gradient propagation and stabilize deep networking training and also addressing the vanishing gradient issues also. So with the help of this R2U-Net, easily capturing both features and contextual information easily here, and also always helpful to achieve the improved segmentation accuracy and boundary delineation also, especially in the field of medical segmentation, medical images and so on, and also very good and suitable for complex medical image tasks, and also it may be lesion or tumor segmentation. Let's go this general architecture where taken for some medical images. So as we discussed here, it consists of input images where you can do with the pre-processing. Then it consists of alternate combination where it consists of convolution layers there, ReLU activation function is there, and everything is there. Upsampling is there, downsampling is there, and segmentation. The thing is, whatever you're getting, the final segmentation map is there. Once go for R2U-Net, you will get the final segmentation map where we get the